the last part, we talked about primitive data types. In this part, we will go into the other data types, the non-primitive data types. First of all, we have a look at some non-primitive data types Java already provides, the string and the array. Let's have a look at the array first of all. The array is a group of multiple items of the same data type. So here we have an example for an int array. The length of the array is 5 and the data type is, as mentioned already, integer. An array has an index starting with the value 0. Over this index we can access single elements. An array has always a fixed size, so you can't change the array size in the process of using the array. We have the possibility to create multi-dimensional arrays. Those arrays have the ability to store child arrays on their index positions. In this case, we have a multi-dimensional array with the child array integer, so every child must be also an array and contain integer values. So with this knowledge we can have a look at the string data type. The string data type is an array of characters. So every string is defined with a fixed length. So we cannot change the length of a string. The data type is always char. That's all a string is doing in the background. To create a new string with the current string value and another string value, those strings get merged together with an array's copy of. With an array's copy of, we can join multiple arrays into one array. So we are creating an array with a new length and inserting the values from the old arrays. So that's it with non-primitive data types. We learned they could hold multiple values. They should always start with an uppercase letter so we can identify them. And they are built from primitive data types always. They have nothing other than primitive data types. So now let's have a look in our IDE. First of all, we are creating an int array. We are defining the data type before the square brackets. Then we use new int to create the array and curly brackets to assign values into our array. Here we are using just some random int values. Then we are using the systemout function to print some elements of the array. For this we are using the variable name followed by square brackets, and in those square brackets the index we like to access on the array. We are doing this for a couple more index positions. So we write a system out for index 2 and a system out for index 3. After this, we run our application. And now we can see that our values from our array got printed. Now let's take a look at the string type. The string could be defined with the string class and initialized with the quoting marks. Inside the quoting marks we write our string. We system out our string 2 and run the application again. There we could see that our string test has also been written to the console. Next, we are creating a char array. We want to represent the same string as a char array so that we can see that we can get the same output. Therefore, we are creating a char array with the values for the test. When we finished creating our array, we also create a system out to print the index elements of the array. Therefore, we are chaining every index with a plus, so we get an output of every value of the array chained. If we have done this, we again run our application. Here we could see that we are not getting our wanted output test, we are getting a number. This is caused to the char is just a number in the background, and by chaining these chars directly after each other, system output then thinks he should use the int output. So it is not printing the actual char values, but is printing their int value. Let's have a look what's happened if we just print the value on the 0 index. Here we could see that the application actual prints the value of index 0. This is caused to that there is a char println function that then prints out the char value and not the int value. If we also chain the other index values with quote marks, the application can only print a string that is built by the index values. Therefore, we are getting the test output we wanted. With this, we already seen that a char has an int value in the background, and we have seen how a string is built. If we cast our char value to an int, we also get the output of the int value. We can replace the char value in the char array with the actual int number, and we will get the same output as we have the char there. So now let's have a look at strings. Here we need to have a look at something because strings can have different behavior. That's caused to that strings have different ways to get initialized, and so on have different cases we need to have a look on. We use our variable for test we created earlier and check if it's equals to test. Also, we're looking at is it the same as test. For both of the checks we get true at this moment because both of them uses the same object, the JFM managed object with the upper quotes. In the next check, we create a new string class and give it the value test and check if it's same our variable. There we get the output false. This due to that with initializing a new string, we create a new object that is no longer the same object as with our variable. There, the object is used from the Java virtual machine. The Java virtual machine, in this case, creates one object which is used in every position. We're using the upper quotes directly and not using new string. So those objects from our variable and the new string are two different objects and so not the same. We are creating some new variables and have some checks on them. So they are also not the same because the first variable is created with new string and the second variable is created with the object from the Java store. If we check the third variable and the first variable, they are the same because they are both used from the store. So the same check only checks for the object stored in the JFM. The equals check does a check for the content of our object. In this case, if we use the equals check, we will get the correct outputs. So now let's have a look at adding some values to an already existing string. Therefore, we'll create a fourth variable with the value of the third variable. First of all, we are just printing the new variable. And as we see, the value is the same. To add some content to our variable, we need to access the variable directly and give it a new value. Therefore, we use our third variable and add the string isAttest. So if we now run the application, the value isAttest gets appended to our fourth variable. When we do this with our third variable, this also works. We can replace our variable with the variable itself and the new content we like to add. Also, our variable 4 got not changed. It stayed the same. This is because our third variable gets assigned with itself and a new value and is no longer the same object. Therefore, the object for our fourth variable is the same. And that's it for this part. In the next part, we will go into basic building blocks for every programming language. So we have a full basic of Java then. After this, we will go into object-oriented programming in the next chapter. So let's stay tuned and see you in the next part.